Hi, and welcome to my tutorial on pathfinding for a 2D platformer. I am Skiko and I will show you how I managed to implement a pathfinding code in GameMaker Studio 2. This tutorial is split in 3 parts for better understanding. It is my own code, so it can be improved and has to be adapted to your own game. I want to show you in this tutorial the theory on how we can implement it in GameMaker. Right now, you are seeing the final results. Player is in blue and enemies are red. Each time I press S button, enemy will go to the player's position. As you can see, enemy will find the player and then build the path to go to the player's position. You can notice that there is no collision between players and enemies because I want to focus on pathfinding. For the moment in my project, I have only a very common code to move the player and a common code for the collision system. I will not explain how it works because it has been explained very well in many tutorials. So if you don't understand what the code does, please see tutorials from Untitled or Heartbeast. There will be a link in my description. I will just show you the code and do a quick overview. So I have a blue player, 16 by 16 pixels, origin is middle center, collision mask is automatic. Then I have a red enemy, 16 by 16 pixels, origin is middle center, and then I have a gray sprite for the collision. It is 32 by 32 pixels, and be careful, the origin is top left. Collision mask is automatic. Then there is the object player. There is a create event where we initialize the player variables. So we have max speed, the game gravity, the acceleration, the game friction, the jump height, the vertical speed and horizontal speed. Then the step event, if we press left or right, we will add the game acceleration to horizontal speed, and horizontal speed cannot be beyond max speed with the clamp function. If we don't press any left or right key, then we will have game friction with the left function. Then there is jump code. If there is a collision object under the player and we press jump, we will add jump height, and if there is no collision object under us, we will add the game gravity, and then we will call the collision script. In this script collision, it is very common code. There is 2 parts, one for horizontal speed and one for vertical speed. So basically, if we don't collide, we add horizontal speed and vertical speed, but if we collide, we will add only 1 pixel until we are colliding to the collision object. In my enemy object, I have no code for the moment. In my collision object, I have no code neither. And finally, the room, which is 960 by 540 with a green background, and there is some collision objects in the room. If we run the game, we have a basic player with a jump and a collision system. Okay, let's talk about theory now. We have to tell our enemy where there is a collision object and where there is an empty space. So we will build a grid to tell him where there is a collision object and where there is an empty space. We set -2 if there is a collision object and -1 if there is no collision object. When it is done for all the grid, we will build every path where our enemy can go. So we will write 1 in each square enemy can go from his actual position. And then from this new position, we will write 2 for each position he can go from position number 1, and so on. The position where enemy can go depends on your own rules. For this tutorial, we will choose 6 movements: left, right, jump 1 block horizontally, jump 1 block vertically, 1 diagonal jump, and 1 fall. We will detail it later. For your information, this is based on A* algorithm. When a number is the same square of the goal, we will stop filling the grid and then select the right path. Then the enemy has to follow this path. Okay, let's start with the first step, initialize the grid. So we will create a sprite called s_grid. It has to be the same dimension of the square of the grid. For this tutorial, I choose the same dimension as the sprite collision mask because it is easier. So sprite will be 32 by 32, origin top left, and I paint it in beautiful purple color. I create an object called O_grid with a sprite called s_grid. I will show you a drawing of the grid that we will have in our game. You can see that my grid will be with 30 square width and 17 square height. Each square are 32 by 32 pixels, and be careful, grid starts at 0. We will place the grid object into the room at 0, 0. We want to move this square through all the grid and see if there is a collision with collision object. If there is a collision, we will put -2 into the grid, and if there is no collision, we will put -1. Okay, so let's see how we can do that. We go to object grid, and in create event we add two variables which are cell_width and cell_height. Those are 8 and width of 1 square in my grid, so both variables are 32. Then we will add a room start event. We choose a room start event because it's an event that is triggered one time once all the objects in the room has been created. And we need to have all the collision objects created to put the -2 or the -1 into the grid. In this event, we will create two local variables, hCell and vCell, which correspond to the number of horizontal square and vertical square. To calculate this hCell, we need the total width of the room, which is get with the function room_width, and divide it by cell width. We have to seal the result to be sure to have an integer on the grid cover all the room. Then we will create a grid as a global variable because this grid could be used by all the enemy. The grid is created with the function ds_grid_create, and the number of width square and height square will be hCell and vCell. Then we will have a first loop that will go through all the hCells, and into this loop we will go through all the vCells. Then we will test if there is a collision with object O_collision with the function placeMeeting. In this function you can see that we write I multiply by cell_width and G multiply cell_height to know the exact position in the room. Indeed, when we create a grid, we can set only the number of height cell and width cells. There is no dimension for the cells. Then, if there is no collision, we will put -1, and if there is a collision, we will put -2. To see if our grid is functional, we will add a draw event, or you can also put this code in draw_GUI events. So in draw event, we have to check if the JS grid exists first. If we do not test it, it will throw an error. If it exists, we will loop through all the grid with the same two loops as before. And for each square, we will get the value of the grid with the function gs_grid_get, and put this value into a local variable called value. Then we will draw this value in the screen with the function draw_text_transformed. We multiply by cell_width and cell_height to know the exact position in the room. And then we add 8 pixels to center the result in the square. So let's test it, and okay, yes, it works, great. Now we have to fulfill the grid with every movement that the enemy can do. We can skip the draw event in object grid because it is useless now. Go to object enemy and add a step event. We will put a basic code. When we press S, we want to fulfill the grid. So we call a script called scr_fill the grid. On this script, there will be 4 arguments. Argument 0, the x coordinate position of the enemy into the grid. Argument 1 is the y coordinate position. Argument 2 is the x coordinate position of where we want to go. And argument 3 the y coordinate position of where we want to go. To get the x coordinate position in the grid of an object, you have to floor the real position and then divide by cell underscore width. Same thing to get the y coordinate. In my tutorial, we will take the position of the player as the goal. To get the coordinate of the player, it is the same thing as the enemy. Okay, let's create a script called scr underscore fill the grid. I create a group called script pathfinding. In this group, there will be all my script needed for pathfinding. In the script, we will add local variables. So there will be ax, which is the x coordinate of the start position, and then there will be ay, which is the y coordinate of the start position, and there is x goal and y goal, which is the coordinate of the goal. And there is pathfound. We will store into this local variable if there is a path to reach the goal position, and then there is n and I. It will be used when enemy is falling. We begin to set variables pathfound to 0, which means that there is no pathfound for the moment. First, we will copy the global grid to a new grid which will be specific to the enemy. To do that, we create a grid with the same dimension of the global grid with the function ds underscore grid underscore create. And after, we copy all the global grid into the grid of the enemy with the function gs underscore grid underscore copy. Then we will create a list where there is all the points that we have to check. Indeed, there might be several points as we see in this example. The enemy can go in each square with the number 1. So we have to check for every one where the enemy can go from these points. So the list will be like this. We store the coordinate of each point. So first the x coordinate of the first point, and then the y coordinate of the first point, and then the x coordinate of the second point, and so on. So this list will be used to store the data of all the points that we are currently checking. At the beginning, we have only one point, the point where there is the enemy. So we add this point to the list with the function ds underscore list underscore add. Then, in the grid of the enemy, we will set 0 at this point with the function ds underscore grid underscore set, because it is the point 0 at the beginning. We will have a first loop with I. It is the number that we will set into the grid of the enemy. So we will check all the points in the list, and if there is a square that the enemy could go, we will set in this grid the number I. So we start the loop at I equals 1, and then we will do I plus 1 for the next loop when all the points are done. The loop will stop when I equals 200. It means that the enemy can do 200 movements until the loop stops. Put a big number to be sure that he could reach any points of your room. In this main loop, we add a local variable called size underscore list, which is the dimension of the list with the function ds underscore list underscore size. It will be useful to stop the second loop. Into this main loop, there is a second loop to go through all the points that we have in our list. It begins to j equals 0, and it will stop when j is inferior to size list, and there is an incrementation of 2 because in our list the coordinate of x of a point is one line j, and the y coordinate of this point is the next line j plus 1. So to go to the next point, we have to have an incrementation of 2. It means j plus 2. In this loop, we will store in local variables ax, the x coordinate of the current point that we want to check, and in ay, the y coordinate that we want to check. Then we put n equals 1. It will be explained later. We want to know if the enemy can go to the right, so if he can go to the right, it means that the next square to the right is empty and the square under the next right square is not empty. So the coordinates of the next right square from the enemy is ax plus 1, ay, And if it is empty, we have this square equals to -1 into the grid enemy. And the coordinates of the square under the next right square of the enemy is ax plus 1, ay plus 1. And if it is not empty, it means that in the grid enemy, it equals to -2. If these two conditions are satisfied, we can go to the right and we will add this point to the point list with function gs underscore list underscore add. And we will set in the next right square the number of I into the grid enemy with function gs underscore grid underscore set. If we can go to the right, we can skip all the other movements because it is impossible to make other movements. In the movement set that I choose, it is like this. So I can put a else statement after my if statement because we know that every other movement will not be possible. Then we will check if we can jump one block vertically. So if we can jump vertically, it means that the next right square is not empty and the square above the next right square is empty. The coordinate of the next right square is ax plus 1, ay, and the coordinate of the square above the next right square is ax plus 1, ay minus 1. If these two conditions are satisfied, we set the number I into the grid of the enemy and add the point to the point list. If we can jump vertically one square, we can skip all the other movements because it is impossible to make other movements. It is the same logic as before, so we can put a else statement after the if statement. Then we will check if the enemy can do a diagonal jump. It is the same logic as before, but with 3 conditions, as you can see in the drawing. I will not detail it because it is exactly the same logic. Then we will check if the enemy can do a horizontal jump. It is the same logic as before, so I will not detail it again. So check the drawing and see my code, it is the exact same thing. For the fall, it is a little bit complicated, so I will explain it. If we can fall, it means that the next right square is empty and the square under the next right square is empty too. So we can fall. But the question is how many squares the enemy can fall. So we have to check every square under and see when we will have a square which is not empty. So we will have a loop and check every square under. We will start at coordinate ay plus 2 because we know that ay plus 1 is already empty. Then we will read this square in the grid enemy with the function gs underscore grid underscore get and put it into the local variable a. The condition to break the loop is to have a equals -2. And we also add another condition for safety. If we are beyond the dimension of the grid, we want to stop this loop. Ay plus n correspond to the y coordinate of the square, so if it is more than the height of the grid, we can break the loop. So when we will finish with this loop, we will check if the square with y coordinate ay plus n is -2, and if the square above this square is empty, and if these two conditions are satisfied, we will put into the grid the variable I and add this point to the point list. Then we will do the exact same thing for the left side. Be careful to set the n variable to 1 in the beginning, because you can fall to the right and the left. And this is why we put n variable to 1 at the beginning of the loop, because we have to reset for each point that we are checking. Then for the movement, it is the exact same logic, so I will not explain it again. You can see that ax plus 1 becomes ax minus 1 to check the square left side. So we will run this code for all the points in the point list. After this, we will have the point list with all the points that we have checked and all the new points that we have added. So we have to delete the previous point. We know where is the beginning of the new point because we store in variable size list the size of the point list before adding new points. When we add a value to the point list, it will be added on at the end. So variable size list contains the size of the list point at the beginning. So I can make a loop and delete the first point with function gs underscore list underscore delete and do that a number of times equals to the size of the list. So I make a for loop with k equals 0 and k inferior to size underscore list. You can notice that the position of the first point is 0. As you can see, this code is placed after the second loop, and when the second loop is done, we will cut the point list to have only the new points and go to the main loop to update the I and update the size of the list, and then go to the second loop. We will see if it works. Create a draw event in enemy object and we will draw the grid. Don't forget to put draw underscore self at the beginning. We will have two loops and draw the content of the GS grid. It is the same logic as for the grid object. I just add a draw set color to black in order to see better in the room. And in the create event, I put the variable gs underscore grid pathfinding to no one in order to not have an error. Okay, let's run the game. Okay, great, it works. We can see that there is a number everywhere the enemy can go. But we don't take into account the X goal and the Y goal. So we will add code to see if we reach the goal. In the second loop, we will test at the beginning if the point is the same as the goal, and if it is, we will break the second loop and set the variable pathFound to 1. And then we want to break the main loop as well. So we will test the variable pathFound, and if it is 1, we will erase the point list on the grid of the enemy and return the pathFound to know if there is a possible path to reach the goal. And then break the main loop. When you create a data structure like gs underscore list or gs underscore grid, you have to delete it when you have done with it, because it takes up memory. We will not delete gs underscore grid for debugging purpose, but don't forget to do it. Let's test it. We will see if we stop filling the grid when we reach the goal. It works, cool. So we finished the first step. See you next time to see how to build the path for the enemy. Also, I made a game in GameMaker Studio 2, so if you have questions of how I made this or this other thing, feel free to send me an email. Bye!